Textile belt tolerances. The width tolerances listed in Table 5.1 are the commercially accepted standards of the conveyor belt manufacturing industry. Tighter tolerances may be specified by agreement between the individual manufacturer and his customer. Zero plus or zero minus tolerances. If a customer specifies a 0 plus or a 0 minus tolerance, the full tolerance still applies to the belt. For instance, if a customer requests a 26 in slitage belt with a -0 tolerance, the tolerance will read 26 in plus 3/8, 0, but if molded edge plus 3/4, 0. This method of tolerancing is being used for clarity and simplicity and takes no stand on pricing a belt based on plus tolerances. Tolerances on lengths. The permissible tolerances for the lengths of conveyor belts, measured loose, are given in Tables 6.2 and 6.3 and as specified in ISO 251. A. For endless belts, so delivered and mounted. B. For open belts. Textile belt test method. Test method. Below are the list of the tests against various standards. ASTM International ASTM D378 standard test methods for rubber elastomeric belting, flat type. ASTM D2228 standard test method for rubber property, relative abrasion by pico abrader method. Canadian Standards Association CAN CSAM 422, M87, fire performance and anti-static requirements for conveyor belting. International Organization for Standardization, ISO, mainly including ISO 14890 conveyor belts, specification for rubber or plastics covered conveyor belts of textile construction for general use, ISO 22721 conveyor belts, specification for rubber or plastics covered conveyor belts of textile construction for underground mining, ISO 4195 conveyor belts with heat-resistant rubber covers, heat resistance of covers, requirements and test methods. German DIN specifications mainly including 22102-1 conveyor belts with textile plies for bulk goods, dimensions, specifications, marking. 22102-2 conveyor belts with textile plies for bulk goods, dimensions, specifications, marking. 22109-1 conveyor belts with textile plies for coal mining. Part 1, monoply belts for underground applications, dimensions, requirements. Bow of conveyor belt. Bow is the concave deviation of the edge of the belt from a straight line between 2 points along the belt edge. Camber is the convex phenomenon, on the other edge of the belt. Bow is measured by unrolling at least 50 feet, 15 m, and more preferably 100 feet, 30 m, of the belting from a shaft-supported roll onto a flat surface, so there is no tension on the belt. Place a tape or string between 2 points along the belt edge. Measure the belt length between these 2 points, and also the distance at the midpoint of the length between the belt edge and the tape or string. The amount of bow is the ratio of the distance, midway between the above 2 points, between the belt edge and the tape or string, and the tape length between the 2 points. To express it in percent, calculate the ratio in hundredths and multiply by 100. For example, the point-to-point length of 100 feet, 30 m, has about width of 18 in, 450 mm or 1.5 feet, so 1.5/100 × 100 equals 1.5% bow. Bow may not be troublesome. It may pull out when the belt is tensioned and operate satisfactorily. The main causes of bow are: A. Bowed filling yarns transversely across the fabric of the carcass, B. Crooked slitting of the belt into a narrower belt, and C. Storage of a belt on its edge when the floor is damp or water and or other liquids reach the belt edge on the floor. Abrasion test. The abrasion resistance is measured by moving a test piece across the surface of an abrasive sheet mounted to a revolving drum. It is expressed as volume loss in cubic millimeters, for instance 150 millimeters raised to the power of 3. A smaller number indicate better abrasion resistance. Elongation test. The total belt elongation consists of an elastic, which recovers, and a plastic, which remains, portion. As per ISO 9856, a belt sample is subjected to a sinusoidal cyclic stress that varies from 2 to 10% of the belt's nominal breaking strength to 10%, because this is a typical operating range for textile conveyor belts. After 200 cycles, the amount of permanent elongation of the test piece and the amount of elastic elongation produced by the force differential are recorded from a force elongation. Elongation test. Typical permanent elongation values: polyamide, P, 1.02.5%, polyester, E, 0.51.5%, aramide, D, 0.250.75%, steel, 0.10.25%. Other, static, tests, for example as per DIN 22102, require a reference tension of 10% of the nominal belt breaking strength. The maximum total elongation for EP belts is 1.5, 2.5 or 3.0%, depending on belt class. Rheometer test. A rheometer test identifies most of the problems in a rubber compound. Test procedure: an uncured sample is placed between two dies. The lower die oscillates. The upper die is connected to a sensor to measure the torque response of the rubber at the deformation during the vulcanization process at a constant temperature. Rubber strength and elongation. Density test. Tear resistance test. The tear resistance is the quotient of the force required for a test piece of specified shape and size with a defined cut to resist tear propagation. The force is acting in the direction perpendicular to the plane of the cut and of the test piece thickness. Separation resistance adhesion test. Normal minimum requirements are 6 nmm between plies and 4.5 nmm between cover and ply. Hardness test. It is not common to determine hardness requirement. Usually a new belt cover will have a hardness between 55 to 70 degrees Celsius. Spirit burner test. A small piece of the conveyor belt is held over a spirit burner flame. After a certain time the burner is removed. The duration of flame and glow has to be within a specified time limit.